My project is titled Identifying the JNK-JUN Signaling Pathway to Block RES Signaling in VPS4B Null Osteosarcoma Tumors and was conducted under Dr. Hansen at the UConn Health Center. Molecular biology is a field that I've grown to love over the past few years. It's unfathomable that we are able to experiment on such a micro scale. This field is the basis of how we understand disorders, diseases, and essentially the human body. I first expressed my fascination for this field to Dr. Hansen, and after a few conversations, he explained to me his current works with osteosarcoma. Osteosarcoma is the most common bone cancer and accounts for 40 to 60% of all bone tumors and 7% of all adolescent cancer. Since 1984, a combination of therapeutic approaches and chemotherapy has given patients 5 years max for survival. There's thus a need for new approaches. Dr. Hansen and I discussed the possibility of a synthetic lethal approach to attack the tumors. In this approach, inhibitors would be created to block signaling pathways in the tumor cells, thus inducing apoptosis in the treated cells. Logically, the first step was to identify which signaling pathway the cells were actually using, and this became an engaging research project for me over the next few months. This research took place at the UConn Health Center at the laboratory of Dr. Mark Hansen. It lasted from June 2017 to August 2017, a total of 3 months. My mentor and I developed the problem question and hypothesis together, and from then on, I was responsible for the protein analysis, Western analysis, data analysis, and interpretation all independently. Prior work done by the Hansen lab found that mutations of osteosarcoma tumors lead to the loss of the VPS4B gene, which is required for regulating growth factor receptors. The cells are then forced to rely on RS signaling. Previous reports suggested that the JNK-JUN pathway was downstream of the RES signaling pathway, so I hypothesized that the tumor cells are using the JNK-JUN signaling pathway to survive. If we can confirm this, then we can then create inhibitors to block the JNK-JUN pathway. My project goes in line with Dr. Hansen's lab work to study the synthetic lethal approach on osteosarcoma. To test this hypothesis, I conducted a Western blot experiment with 2 different mutations, U2OS cells and SAOS2 cells. The membrane was processed with the anti-c-Jun antibody specifically to target the c-Jun protein. Images from a ChemiDoc imaging system did not initially show the band I was looking for. However, over the 3-month period, I was able to recognize problems and refine my Western blots to reap the results I wanted. I finally found a band around 36 kilodalton, proving that osteosarcoma cells express the c-Jun protein and use the JNK-JUN signaling pathway. Thank you for considering my project for this year's JSHS.